Write the partial fraction decomposition of the given rational expression. So we have x squared over x minus 5 squared times x plus 3. And we see that in the denominator we have a repeated linear and a non-repeated linear. So we have to have a denominator for each of the successive powers of that repeated linear. So we have to have one for x minus 5 and one for x minus 5 squared. Now since they're linear, then we'll have constant a and b, constant numerators, and x plus 3 is also linear, so it will have a constant numerator. So what we'll do is we'll multiply both sides by the lowest common denominator, which will be the x plus 5 squared x plus 3. We're going to multiply that on both sides so that the denominators cancel out. So we have x minus 5 squared x plus 3 on the left and x minus 5 squared x plus 3 on the right. And of course what's going to happen is we're going to distribute this thing here. And in the first term, one of the x minus 5's will cancel. We'll be left with a times x minus 5 by x plus 3. And in the second term, the x minus 5 squareds will cancel. So we have x plus 3 times b. And in the last term, the x plus 3's will cancel, and we'll just be left with c times x minus 5 squared. And then multiplying that out, we wind up with what we have here. X squared is a times x squared minus 2x minus 15 when we multiply this. And then we can multiply through by b, and then we can multiply out the x minus 5 squared. Now, we'll multiply through by x, and we'll have ax squared minus 2ax minus 15a. And I'm going to go ahead and line up terms here. So in other words, we'll have a plus bx plus 3b. So I'm going to put the bx here with the minus 2ax, and then the plus 3b with the constant minus 15a. I'll do the same thing when I multiply through by c. So we'll have plus cx squared minus 10cx plus 25c. And now this is going to give us a system of equations, because all we have in terms of quadratic terms over here on the right is ax squared plus cx squared. And if that's equal to x squared with an understood 1 out front, that tells us that a plus c must equal 1. And then we have minus 2ax plus bx minus 10c over here on the right, but we have no linear term over here. So that tells us that the linear coefficients, minus 2a plus b minus 10c, must equal 0. And then the same thing with the constant coefficients. There's no constant term on the left, so those constant coefficients, minus 15a plus 3b plus 25c, must equal 0. Now we see that we have a system of equations here, and this system has one equation that has just a and c, and then two that have a, b, and c. So what we'll do is we'll call this one equation 1, and this one equation 2, and this one equation 3. And we can eliminate b from this pair so that we'll have two equations that just have a and c. So we'll multiply equation 2 by minus 3 and add that to equation 3. And what that'll leave us with then is 6a minus 3b plus 30c equal to 0. And we'll add that to equation 3. So minus 15a plus 3b, and then here's the whole reason why we're doing this, so the b's cancel, and then plus 25c equals 0. We'll add those together, and we'll wind up with minus 9a, the b's go away, plus 55c equals 0. And now I have two equations that have just a and c. And so we'll multiply equation 1 by negative 9, or by 9 rather, and add it to this equation, so that when we add them together, the a's drop out. So we have 9a plus 9c is equal to 9. And when I add those together, we get 64c is equal to 9. And now we just divide both sides by 64, and we find that c is equal to 9 over 64. Now from that, we can easily get a because we know that a plus c is equal to 1. So we'll go a plus 9 over 64 is equal to 1. And so we'll subtract 9 over 64 from both sides, and we'll turn 1 into 64 over 64. And we'll find that a is equal to 55 over 64. So now we have a and c. So all we have to do now is take this equation that has minus 2a plus b minus 10c is equal to 0, plug in for a and c, and find out what b is. So we have minus 2 times our value for a, which is 55 over 64, plus b, and then minus 10 times our value for c, which is 9 over 64, and set that equal to 0. Now we'll have minus 55 over 32 when we cancel with the 2 and the 64, plus b, and then we can do the same thing with the 10 and the 64 by canceling out the 2's. And so we'll have minus 5 times 9 is minus 45 over 32 is equal to 0, which will give us b minus 100 over 32 equal to 0. We can add 100 over 32 to both sides and then reduce it by dividing both sides by 4, and we'll have b is equal to 25/8.